Students, so this is our SMAW weldment that I'm going to be demonstrating for you today. And so after we have made sure that our machine is all set and ready to go, we've done our inspection of all of our cables and everything, and our booth is ready to go, we are going to set up for our SMAW. So the first thing we're going to do is we're going to cut 3 pieces of 1/4 inch metal at 6 inches, and 6 inches is going to be the length of all of our weldments. And this is the way we're going to set this weldment up. You're going to take your first 2 pieces of metal and lay them together as such, and then you're going to take your first piece of metal and split the 2 other pieces as such. Okay, so it'll be half on top of this one, half on top of that one. All right, that is going to give you your lap welds. Okay, then you're going to find a rod butt somewhere or an electrode. Make sure that your machine is set up properly for SMAW, and I've demonstrated that in another video. And then you're going to create a tack weld. A tack weld is just simply touching on the outside. Now, we do not want to tack it on both sides here, because if we do that, then we won't be able to get this piece out, and we're going to need this piece to create a fillet weld here, and I'll show you that in a minute. But we're going to tack it on the outside as to not to interfere with our welds, where our welds are going to go. Okay. Now, I like to slide it off of the table just a little bit. This is just my personal preference, but I like to slide it off the table just a little bit. And the reason that you tack your metal in place, for a couple of reasons. Number one, it helps to keep your metal secure as you're welding so that you don't move it with your electrode. Also, metal expands when it heats up. You don't want to get to the end of this weld and all of a sudden find that your weld has moved a whole bunch. Okay, so I'm going to put a slight tack right here on the end, and then I'm going to flip it around and put a slight tack on the back end right here as we set up for our SMAW weldment. Okay, a slight tack there. Now I'm going to flip it around and do the same thing on this side right here, right in the corner there. Okay, now I'm going to take this piece of metal that I used here, and I'm going to put it in the center of this top piece. Now, it might be a good idea if you have a 4th piece of metal, and it doesn't have to be 6 inches. If you've got one that's a little short, that's fine, to put in there to kind of hold it in place. And you're going to take your 3rd piece of metal and you're going to put it in the center of that top piece of metal, and we're going to tack it right on the edge here, right on the edge. Okay, and it's important that we get it in the center. All right, and we'll watch here. Okay, Sometimes this is going to happen. You see where it's moved over to the side here. That's fine. Just take and push it over where you want it. Hold it in place. Hold it in place, and we'll tack it again. And sometimes this E7018, it builds up a little resistance on the end of it. Just hit it on your table to burn that flux off of there. Okay? To burn that end off of there. That's the one thing about 7018. And then we'll drop it into our rod bucket. And then we can take this piece and put it out of the way because I'm going to use that for a later weldment. And this is what your weldment should look like. Okay? Now, it's important that as in your handout, you remember this. You remember the step progression, what I call the step progression of each weldment. This is a 2-pass. This is a 3-pass. This is a 2-pass. This is a 3-pass. Okay? 2, 3, 2, 3. 2, 3, 2, 3. You must have this set up like this before you start your first weld. Okay? It's important that you have your entire weldment set up before you start your weld. Right? On a 2-pass weld, it is important that you get your electrode in the correct angle. For a 2-pass weld on the first pass, it is important that you are running almost perpendicular to the metal at about a 90-degree angle. And again, if you want to pull out your junk piece of metal, if you've got a little piece that's 2 or 3 inches, just enough to stick it up underneath there so the metal's not rocking while you're welding, that's fine. You want to run almost a 90-degree angle perpendicular to the weld, about 15 degrees in direction of travel. Your E7018 is a high carbon or high hydrogen electrode, so it's pretty much a drag electrode. So we're not using any type of circular motion. We're not using a stitch motion. We're not using a J motion. We're just simply dragging the electrode. The reason that we're using 6-inch pieces of metal is that it will take almost the entire electrode about down to where the numbers are. If you look real closely on any electrode, you'll see the numbers there that identifies what electrode this is. That is about how much you should be burning on these electrodes. Okay, don't burn past those numbers for me. Okay? That's about what a 6-inch bead should take. All right? So you're going to strike your arc. Your electrode's going to be in about this position, and then you're just going to drag it slowly as you move it in this direction. As you are moving in this direction, you will watch what we call the weld puddle as it washes up onto this crack right here where the pieces of metal meet. If you can't see that weld puddle washing up onto that crack, then you're too far out this way, and you need to move your electrode in a little closer. If you see the weld puddle washing up too high on here, then you've got the wrong angle, and you need to bring it back down a little bit. If you see the arc from the current jumping up on here, then you're too close. You need to bring it back just a little bit. All right, it's all in the manipulation of the electrode, of the lightsaber, young Jedis. Okay. All right. So Not quite. I mean, you don't want to be quite 90 degrees, just a little bit off of 90 degrees, and then about 15 degrees in direction of travel. And then you're going to strike your arc and then just pull it in the direction of travel. When you get to the end, the way you're going to end your arc, end your bead, is you're going to do a little circle, 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 and then strike it back up over the top of the weld bead. So circle, 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 strike it back up over the weld bead, or two circles. It doesn't matter, depending on how much electrode you have left. All right. So let's demonstrate that for you. First pass on a two-pass bead. Again, with E7018, our setting is at 85 amps. We're using a 3/32 electrode. And here we go. Okay. You can see my electrode's almost perpendicular to the weldment. I'm striking my arc. And just dragging my electrode in a back motion. The cool thing about 7018 is I can feel the flux pretty much as it melts off of the electrode itself. And so here I am at the end. Circle, 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 and back up over the top. And I'm right about down to the numbers. That's about how much electrode you should have left. All right. Every booth should have a rod bucket. You'll drop it in the rod bucket. Get your electrode holder out of the way. We'll take our nice chipping hammer. Again, this is a chipping hammer. It's not a 16-pound framing hammer. We'll chip the slag off of it. You'll notice I'm not beating this thing to death. I'm just gently chipping the slag away from it. And there's a pair of pliers here if you need to hold on to it with the pliers, because it is a little warm now. You want to get all of that slag off of there so that when we do our next pass, we don't have any type of slag inclusion, which creates air pockets. And air pockets in metal, air pockets in welding is a bad thing. We don't want that. Okay. And we can take our wire brush and we can wire brush it. Again, making sure that we're getting all of that slag out of there. Making sure that we don't have any type of slag inclusion. Still a little bit right here in the corner. Your first pass on this should be relatively flat. Get my big fat finger out of the way there so you can see it. That's pretty much what it should look like on your first pass. Okay, on your first pass for this. Right? However, if I can see where the metal is joining to the bottom piece of metal, then that tells me then you were too far out. And that's a weak spot in that metal. Your second pass is going to be at a 45, and think that you're driving it right at the top toe of that first weld. All right, the top toe of that first weld, and you're going to drive it at a 45. Your electrode's at a 45 of your weldment, and again at about 10 to 15 degrees in direction of travel, so you can watch what's going on in that direction. And then again, when you get to the end, a little circle to deposit some more metal in there, and then strike it up over the top of the weld you just passed. Okay? Again, so we're going to come in at the top toe of the weld, not the bottom toe, the top toe. These are the two pieces of metal that I'm trying to join together. So I want to put it up here. I'm going to pass it right along here. Right? That's why it's important to get this slag out of this joint right here. And then circle back up over the top. Okay? So, let's see if we can do this today. And again, this is a drag electrode. We don't have to do a lot of motion with it. We're just going to simply drag it along. Okay. And here we go. And we're coming right up to the end. So I'm going to do my little circle and back up over the top. And there we go. Into my rod bucket. Oh, lovely, lovely, lovely. I love it when this slag just falls off like this. And again, we can hold it with the pliers on top. Now, there's a little bit of slag left on there, but for demonstration purposes, for what I'm going to show you. If I was, turning it in, I would clean it all up. Okay. Okay. So if you look real close at that, you can see about a third of that bottom pass, okay, and all of the top pass. Okay. Now some of you are looking and going, "Oh, Mr. Clark, what is this right here? I did this on purpose as I was coming off of my last pass." This is what we call an arc strike. All right. This is a no-no. Okay. And what I did when I was coming off, if you were paying attention, if you go back and you look at the video, when I came off, I did this. Instead of coming straight, I come off and I went up here. And let me turn it around here so you can kind of see. All right. Instead of coming here and coming straight, I come up here and I went up here. This also happens a lot of time when we get stuck. We're well, all of a sudden we get stuck. We're trying to strike an arc and we get stuck and we start doing this number. We start doing this. We get arc strikes on our metal. Okay? This is a no-no. We do not want arc strikes on our metal. The reason is, what that does is that creates a incontinuity in our metal. The electrons and the atoms are excited and they're not allowed to line up properly and cool properly. Okay. The same reason that when we are welding on structural steel, we don't quench the metal. We let it cool naturally so that the atoms can naturally cool down and realign properly. Right here, the atoms are, and the bell's ringing for class, so the atoms are not allowed to realign properly. Okay, we don't want this. We want the metal to cool properly, heat up in uniform, and cool in uniform. All right, these are bad things. If you ever go for a plate certification, whether it's SMAW, GMAW, FCAW, GTAW, any of the processes, and you have one of those, even if you buff it off, they have chemicals that they could put on your test and they will find it. All right, so we do not want those. All right, so that is what a two-pass should look like. I will have examples of this sitting on my desk when you come in. The next one that we want to talk about is a three-pass. Three passes are, for me, they seem to be a little bit easier because everything, the electrode is at the same angle every time. We're going to do our first one at a 45 and about 15 degrees in direction of travel. And we're going to drive it right where that joint is. Boom, just like so. Okay, just like so. Okay, and so we're going to weld this one up. Start it right here, 15 degrees in, or I'm sorry, 45 degrees, and about 15 degrees in direction of travel, and just let the electrode do its work. Okay. So. And so we will, and again, you can have a piece of metal back there to kind of hold it up for you. So here we go. We'll strike our arc. And you want to make sure that your weld puddle is joining the two pieces of metal as you pull your electrode back. And here I am at the end, circle, back up over the top. Okay. Now, the reason I'm using a little less electrode is because my weldment is getting a little warm, and so it's pulling the metal just a little bit faster. Typically, I would have you quench this by now into the tank, in the water tank. About every 2 or 3 passes, you're going to want to take and run it into the tank, into the quench tank. Okay. And so let's clear this slag out of the way and see what we got, what it looks like. Still some more slag right there, so we're going to chip it out. You want to try to get all that slag off of there you can. Okay, all right. So, okay. So there's my big fat hands out of the way. It's hard to do with that. Okay. There's your first pass. Okay. Got a few holes in it, but that's all right. We're going to fill them up. All right. We're going to fill them up. Again, this metal's getting a little hot. Getting a little hot. Okay. Okay. All right. So our second pass is going to be at the toe. At the toe. Okay. Look very carefully here. It's going to be at the toe here. All right. And we're going to go real slow across here. We're going to go real slow across here. Across this bottom part here. We're going to go real slow across the bottom part here at a 45. And we're going to fill in right at this bottom toe. Again, 45, 15 degrees in direction of travel. In direction of travel. All right. Okay. So here we go. Okay. And back into my rod bucket. And my chipping hammer. I love it when that slag just falls off of there. Okay, it's important to watch and to make sure that between my metal here, my upper piece of metal, and my weld, that I get all of that slag out of there. Okay, because that is where slag likes to sit. And if I was to run an X-ray of your weld or of my weld, I want to make sure that there's not any slag in there. Another thing, you'll notice that I'm just tapping. I'm not sitting here beating it like I'm trying to drive a 16-penny nail. Okay, you don't want to leave divots in your weld from where you're bam, bam, trying to drive out that slag. Okay, because that can become a discontinuity or deformity in your weld, leaving marks on the weld from the chip and hammer. Okay, see the little pockets right there? Just break them up. And there's other ways to get to them, but we'll talk about that in another class, another time. Okay, there's my next pass. Okay, there's my next pass. I'm dropping stuff off the table. All right. So now my third and final pass is going to be at the top toe of this weld. Okay, the top toe of this weld. And I'm just going to drag it right along the top here. Okay, and when I'm done, I should see, just like this one, I should see about a third of this bottom weld. Okay, 45 degrees, about 15 degrees in direction of travel. 45 degrees to the weld, to your weldment. Imagine that you're trying to push this electrode into that weld right there. Okay, 15 degrees in direction of travel, and then just drag it along. Okay, so here we go. Strike. I like that when that flux starts to come off of there like that. Beautiful. Beautiful, beautiful, beautiful. my electrode pointer here. All right. You can see about a third of that weld right there on the bottom. This one comes up right onto the corner of that top piece of metal right here, nice and uniform across the top there. This is what I'm looking for. Okay, this is what I'm looking for. Okay, and again, I will have these sitting on my desk whenever you come in to work on these. So remember, this is a 2-pass, this is a 3-pass. On the back, this is a 2-pass. Mr. Clark, how am I going to do this one? Think outside the box. There's several ways to do it. Several ways to do it. Okay. You can find some junk piece of metal and prop it up like this so that it stays in place. You can tack it to the table so that it stays in place. Okay, because we're going to be grinding these tables off at the end of the day anyways. Okay, just a little tack right there so that it stays in place. Okay, or find some metal to prop it up in place for you. All right, so 2-pass, 3-pass, 2-pass, 3-pass. All right, and I will have, again, I will have this sitting on my table so that you can kind of take a look at it. Matter of fact, what I'll do is I will weld one out for you and weld it out in stages so you can see 1-pass all the way, 1-pass all the way, 2-pass part way, 1-pass all the way, 2-pass part way, 3-pass part way, and then do the same thing on the other sides. That's what I will have waiting for you whenever you get here. Alrighty, that is your SMAW weldment for B1B. I will see you in the booth. Clark, I'm out.